welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KaiZen's own Scott Cain.
Thank you, William. And thank you, everybody, for taking a few minutes out of your day to come learn a little bit with us. And hopefully, you find this time together valuable, informative, and hopefully a little bit entertaining. So, today, what we're going to do is another case study. And today, we're going to talk about power module cleaning. And I want to shout out my partner on this, Jason Chan. I'm presenting it, but his technical expertise was utilized extensively during this presentation. So, what does this really mean? We're looking to determine the correct cleaning chemistry for an IGBT application with numerous requirements that the customer set forth. And we're going to refer to IGBT for the rest of this presentation. And just in case you're not aware, that's an insulated gate bipolar transistor. So let's take an overview of the project. First off, there's more and more IGBTs out there because of the increase in high voltage and high current applications. So we need more power, and that's why more people are coming to utilize the IGBT technology. And as those applications increase, we learn about new issues. It could be material compatibility, the bath life, what the cleanliness expectations are, why we're cleaning, etc. And this particular customer needed a solution that lasted longer than their current supplier while providing the outstanding rinsing so it can move on through the process and meeting their EH&S pH requirements. So let's talk about the situation. This manufacturer also was cleaning metallized ceramic substrates with copper and nickel and needs a new cleaning chemistry. They were also getting their parts from a multitude of suppliers, so we had to make sure it worked on all the suppliers that were providing these materials. The existing supplier, in terms of the chemistry, worked well on the flux residue and the copper substrate, but it darkened the nickel substrate. And they had to have an extension of their bath life. They were replacing their bath life every 24 to 48 hours, which they really didn't feel was optimizing it and was a cost drain because of having to replace that so quickly. Some more of the requirements, they had to have a solution to clean all the copper and nickel substrates. We talked about the three suppliers. They needed the longer bath life. They're providing a reduction in the total cost. The EH&S team needed a neutral range of pH, anything under 9. And then the machine had a couple of limits that we were required to take into consideration. It could only provide between 40 and 50 psi on the spray pressure and a max temperature of 55 degrees. This is a little bit lower on both the energy, the mechanical energy, and the temperature than a lot of these machines can offer. So we had to modify the production to make sure that we're replicating what they were doing in the field. So with all this information, the flux, and knowing this about the machine, we decided we wanted to try the KYZEN Micronox MX2127. It's a really popular material for us, and it's a single phase chemistry designed to remove the flux from these devices. It leaves a really nice surface condition for the post wire bond and potting processes. And it's effective at a lower concentration, and it can be easily monitored, which is helpful once this goes into production, that they know that they're able to keep it in the concentration range that we advise them to go to production with. So the first thing we did is we did some solubility testing. And what we do is we just take the chemistry and the flux and put it at different amounts of flux to see when it starts to get loaded up. And as you can see here, once we get to the 3, 4, and 5, you can see it's having solubility issues. It's getting loaded up. This is the competitor's one right now. So if we take a look at the KYZEN material, you can see we fully solubilized up to 5% on these, which is really beautiful. It lets us know that the chemistry is going to last longer in the application. So that's answering the first concern of the customers. Hey, we're spending too much money on chemistry. We need something that's going to last longer. When we show this solubilization, that shows that, okay, this is going to last longer as it gets loaded up. Now, cool, we answered that question for them, but that doesn't matter unless they're getting clean parts out of it, right? They have any of these darkening on these different materials. They need a clean place to press from. So the process parameters and the process flow that we did, you can see that we ran everything at 45 psi, just because we wanted to make sure we were in that range. We were at 50 degrees C in the wash cycle. And so These are the process parameters that we ran. And these were the parts as they were received. As you can see, there's discoloration. You can see where the flux is on there, and this is not something that the customer is going to move forward with. Now, once we run that through the Kaizen, just a visual results of this, the Kaizen comes out much cleaner, provide the customer is really happy when they saw these. Let's go back and look at the other ones just for a second. These are how they were received, and this is how they looked once we got them in. Customer was really happy. Now we've been able to prove that we can clean it and it's going to last longer. We're really moving forward with this customer. Another part, they wanted to see what the aluminum pads on the IGBT looked like before and after. And as you can see, the one on the left, dirty, not what the customer is looking for. The one on the right, beautiful. It's really clean area for the next step in the process. So kind of the results and conclusion on this. MX2127 is the best choice for removing no clean flux from IGBT modules. And the reasons are, we look at the pictures, we have the superior cleaning performance, got great material compatibility. As you can see, the copper, the nickel, the aluminum, all three of those materials that were utilized came out clean, no discoloration, no darkening, no oxidation on there. It's got a longer bath life, better rinsability. We saw that when the solubility test, how loaded it gets, the Kaizen was able to go all the way to 5% loading. And the material has a pH under that 9 that the EH&S team was looking for. So all around, the customer is really happy with this. Chemistry lasts longer. They're getting materials clean. They don't have to worry if it's different materials on the same piece that they're sending through their cleaning process. So just a little bit more. Hey, look, we're here to help. You have both the chemistry suppliers and the machine manufacturers. We're all experienced on all aspects of the cleaning process. You guys are busy, you have a lot of things you're trying to do, and validating a new chemistry or validating a new process or trialing something new is kind of hard to do in the field and sometimes has to be taken offline to run these. And we can be an extension of your engineering team. You can just hand us parts and say, hey, clean this, tell me what we did. We have the abilities in our labs all around the world to do this. And finally, hey, we love talking about this stuff. So we're here for you if you want to talk through any of these processes, concerns, issues you have, whether it's from the EH&S side, from the chemistry side, or how to worry about the concentration, anything. We're here to help and make sure your process is as optimized as possible. And just a couple of the frequently asked questions, what type of applications are most popular for these IGBTs? This can be a lot of the high powered stuff. We're talking about maybe solar power, electric cars, and some home appliances are pretty popular then. Was there an OSP on these parts? Yeah, there was. And so that OSP is a protection on there to kind of protect it from tarnishing. And it was great. The customer provided that information for us, so we knew to keep that in mind through the process. But the OSP stayed intact throughout this process. It's always good to relay all that information when we're talking about how we're going to test. And how was the solubility testing done? If you want to read more about it, it's Hansen solubility. That's kind of the scale that we use. But really, what it is taking different loads of the flux with the chemistry at the concentration, for mixing that up, and then seeing what it looks like afterwards. And it's all based off of what's called the Hansen solubility testing and scale. So there's more information available online for that. So thank you very much for your time, and I'll send it back to William.
Thanks, Scott. And thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions that were not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.